Solving systems of equations in 3 dimensions. You might remember recently we solved equations in 2 dimensions, and that was when we were graphing. They were two straight lines, and really what we were looking for is where they intersected. We did that by substitution and elimination. Now we're going to do that in 3 dimensions, which is a little bit harder. An equation in 2 dimensions with just an x and a y makes a line. An equation in 3 dimensions with an x, y, and a z, notice the equations below and notice the ordered triple. This is called an ordered triple, alphabetical, x, comma, y, comma, z. The equations all have 3 variables. An equation in 3 variables makes a plane, an infinite flat surface. So what I'm looking for is the intersection of 3 planes out in space, and they intersect 3 planes at a point. Now they could be parallel and have no solution, and I suppose you could have all 3 planes be the same equation and have infinite solutions. In the problems we're going to do, though, we'll just have a single solution. Here are the steps to solve a system of equation in 3 dimensions. Pick one pair of the equations and eliminate one of the variables. Next, take the unused equation, the equation that you have not touched yet, and pick one of the other equations and eliminate the same variable. If you've done everything correctly, you should now have 2 equations with 2 of the same variables. This is what you've done before, solving a system of equations in 2 variables. Solve that system. Once you solve for both of those variables, you're going to take your 2 answers and plug it in one of your original equations to find the third variable. Normally, your answer is written as an ordered triple. So you put parentheses just like an ordered pair in alphabetical order, x, comma, y, comma, z. The first thing I do when I look at a system of equations in 3 variables, I look at my variables, my x's, my y's, and my z's, and I look and see which one would be the easiest to work with. Looking at the x's, 3, 6, and 12, what I would need to make this work is a common multiple of those 3 numbers. 3, 6, and 12, the common multiple is 12. Look at the y's. Those look nice because they're all the same number. That's going to be the easiest one. And just to point out, when you look at the z's, 4, 5, and 2, the common multiple is 20. The easy one to work with is going to be the y's. If I didn't use the y's, I would use the x's. Remember, the process is to pick a pair of equations, eliminate a variable. I would eliminate, say, x, and then use the equation we haven't touched yet with one of the other equations, eliminate that same variable, and then solve the system. The last step then is to plug the 2 variables you solved for in one of the original equations and find the third variable. So let's use the y's. I'm going to pick the top 2 equations, and I'm going to eliminate the y's. Now, this is nice because I can just do this without a lot of work. I can just add -4 and +4y makes 0. When I add, I get -9x. The y's are gone. +4z and -5z is -z. And 25 and 1 makes 26. Now, to get my second equation, I will take the 2 equations, -6x plus 4y minus 5z equals 1, and I'm going to make a pair of opposites. I'm going to take this bottom equation and make the 4y a -4y. I'll multiply by -1. That equation becomes -12x minus 4y minus 2z equals +46. Now we can add those 2 equations. We get -18x minus 7z equals 47. I have two equations with two of the same variables. That's what allows me to solve. So I'll rewrite those. Negative 9x minus z equals 26, and negative 18x minus 7z equals 47. And I need a pair of opposites. I'm going to take the top equation and multiply that by negative 2. That's positive 18x, positive 2z, and negative 52. Doesn't matter which equation is on top, because you're going to add the two equations, but I'm going to keep it the same. When we add, we get negative 5z equals negative 5. Divide by negative 5, and we get z equals 1. Take that value and plug it in one of the original equations. You could use any of them here, but the easiest one to me looks like the negative 9x minus, and z is 1, equals 26. So I'm going to add 1 to both sides. Negative 9x equals 27, and divide by negative 9, and x is negative 3. Take x and z and plug it in one of the original equations. I'll use the top one. Negative 3 times x minus 4 times y. I don't know what y is. That's what I'm trying to find. Plus 4z, 4 times 1, equals 25. That's 9 minus 4y plus 4 equals 25. This is negative 4y plus 13 equals 25. Subtract 13 from each side. Negative 4y equals 12. And divide by negative 4, and y is negative 3. The ordered triple then is x, negative 3, y, negative 3, and z, 1. Here's another system of equations with 3 variables. Look at your variables and decide which ones would be the easiest. The x's actually look pretty nice. I've got 1, negative 6, and negative 1. That's not bad. The common multiple is negative 6. 4, 2, and 3 for y. The common multiple is 12. 6, 5, and 2. The common multiple is 30. I'm going to use the x's. So I'm going to pick the top 2 and eliminate the x's, which means I'm going to make positive 1x be positive 6x. I'm making a pair of opposites. So my top equation becomes 6x minus 24y plus 36z equals negative 186. I'll rewrite the second equation. And add. We get negative 22y plus 41z equals negative 180. You could use the middle one and the bottom one. You have to use the bottom one because you have to use all 3 equations. But myself, I like the bottom one and the top one because look, you've already got opposites. You've got positive x and negative x. Let's get rid of that 6. I'll rewrite those two right next to each other. Add the 2 equations, and we get negative 7y plus 4z equals negative 3. Let's rewrite both of those equations here and here. These numbers aren't very nice to work with, but we can make it work. The common multiple of 22 and 7 is just 22 times 7, 154. The common multiple of 4 and 41 is 164. So I suppose I'll use the y's, slightly smaller numbers. So I'm going to multiply this by 7. And the bottom equation, I want opposites. I'll multiply by negative 22. Rewrite those equations. I multiplied the top equation here by 7 and the bottom equation by negative 22. This made a pair of opposites on the y's. Now I'm going to add, and I want to point out, it is so easy to make a mistake. You have to be really careful and methodical. I just made a mistake and lost a negative and I had to back up. So here we are, we're going to add. The y's drop out. We get 199z equals a negative 1260 plus 66 is negative 1194. Divide by 199 on both sides and we get negative 6. Now I usually choose the equation with the smallest numbers, which I suppose will be this one. Negative 7y plus 4 times z, which I know is negative 6 now, is negative 3. That's negative 7y minus 24 equals negative 3. Add 24 to both sides. Negative 7y equals negative, actually positive, 21. And y then is negative 3. Pick one of your original equations. I'm going to pick this one. The opposite of x, so negative x, we don't have x, minus 3y, 3 times negative 3, minus 2z, minus 2 times negative 6, equals 28. And this is negative x plus 9 plus 12 equals 28, which is negative x plus 21 equals 28. Subtract 21 from both sides, we get negative x equals 7. Divide both sides by negative 1, and x is negative 7. So there are answers. And our ordered triple then, in alphabetical order, is negative 7 for x, negative 3 for y, and negative 6 for z. One last note here. If you try these questions and are really struggling, my suggestion is, for practice, take this question here and write it down on a piece of paper and try to work it out without looking at my work. If you get stuck, check the work and try it again. Redoing a question until you get it correct, until you understand it, really can help you get the process down. And as I said, probably the most difficult part here is to easily make a simple multiplying, dividing, losing a sign error. So just keep working at it and do your best.